Hi students, today we will discuss about tautomerism. Today we will discuss about tautomerism. So what is tautomerism? Once see okay, tautomerism, it is a special type of functional isomerism. So special type of functional isomerism. So here definition of tautomerism, these type of this type of isomerism, this type of isomerism, the substance which is readily interconvertible different, so substance exist in which readily interconvertible different two different structures, two different structures are different structures in a dynamic equilibrium, dynamic equilibrium. So it is exist two different structures, only one molecular formula. You know isomerism, or the isomerism definition, you know what is that? So a structural formula same, so same molecular formula but different arrangement of atoms is known as isomerism. No, same, this is also one type of special type of functional isomerism. This type of isomerism in which a substance exists in which readily interconvertible two different structures in a dynamic equilibrium. Two different structures in a dynamic equilibrium is known as isomerism. One example we will take CH3 C double bond O C double bond O CH3. This one you can take. So this ketone changes into enol, so that we will call keto-enol isomerism. See here CH2 double bond COH and CH3 will come. So this is this type of isomerism, one example. See these hydrogen, this is a functional group. This functional group having alpha hydrogen, this is functional group carbon. This hydrogen is alpha hydrogen, this carbon also alpha carbon having hydrogens. So here one hydrogen moves to here, this double bond will comes here like this. Readily interconvertible two different structures, same molecular formula. So this is a dynamic equilibrium, readily interconvertible dynamic equilibrium is known as tautomerism. These two structures now tautomers. One more thing is there, here two different hydrogen moves two ways, that is diode system. Second one is triad system. So what is diode and triad systems? Diode system example, so migration of hydrogen ion in two different different polyvalent atoms are, so migration or oscillation of hydrogen ion in two different polyvalent atoms is known as diode system. So here on a definition of tautomer means, tauto in Greek means same, and then mers, MERS, mers means parts, same parts, that is known as tautomers, that is meaning. Okay, here for this one example, cyanide, C triple bond N, hydrogen, it is interconvertible, changes into C triple bond N, H. So here this one is coordinate covalent bond. Here this hydrogen attached to carbon, here hydrogen attached to nitrogen. So one time first carbon, next this is goes to second atom. So that's why 1,2 system or 1,2 are diode system also, we will call that one. Next triad means here migration or oscillation of hydrogen atom or migration of hydrogen ion, it will be attached to third atom, attached to or migration or attached to third atom of the compound. There 1 and 2, first carbon having hydrogen, next it will goes to second atom, that's why 1,2 system or diode system. Here 1,3, that means first carbon having one hydrogen, that hydrogen again goes to third atom, that is hydrogen or oxygen, whatever it, that is 1,3 system also, we will call this is a triad system, triad not triad. So attached to the third atom of a compound is triad system. So example of for that example of triad system example, we will take CH3 CH2 C double bond O, CH3 or aldehyde NH2, we will take NH2 NH2 amine. Now here hydrogen, this is one atom, this is two atom, this is third atom. No, this hydrogen moves here like it is keto, means it will be changes into enol form. How it is? See, same CH3 CH2 COH double bond NH, difference atom where I will represent a different color. NH2, no, one more H, NH and one more H, these one more H join here, so that also I will represent a different color. So that like this. Now double bond here is there, now double bond here will come. See that double bond also I am representing different color. So this double bond will goes to here. That is triad system, because first atom, second atom, third atom, hydrogen moves to here, oscillating here and here and here, readily interconvertibles, two structures. So this is also known as tautomerism. Now some factors is there, tautomerism should be follow what we want to have. See, tautomerism exhibit means how it will be exhibit? At least it is having one alpha hydrogen. Conditions for tautomerism. Condition 1, what to know? Compounds having at least one alpha hydrogen atom should be there, means it is applicable. See, this is functional group, this is alpha hydrogen, this is also alpha hydrogens, this is functional group, this is alpha hydrogen, this is functional group, this is one enough, this is functional group compound, this is alpha hydrogen, or this is also alpha hydrogens, so that only it is applicable. For here some compounds not applicable. What is that compounds? One, see it. This compound, this type of compound, C double bond O diphenyl ketone, like these compounds. Here no hydrogen, this carbon also no hydrogen. This is a functional group. This one we will call B functional group carbon. This is alpha hydrogen, this is alpha carbon, alpha. No hydrogen here, alpha carbon and alpha carbon. Next, one more example. C double bond O H. This is functional group compound. Here no alpha hydrogen because double bonds is there. One carbon is there, 4 bonds between that carbon. So like this compounds not applicable for tautomerism formation. So this is about tautomerism. Thank you.